Now we're going to take our smart contract and deploy it to the blockchain. We're going to deploy the token and also the exchange. All right. So in order to do that, we're going to create some migrations. So I'm going to go ahead and go down to one column here for more readability. And we can see our file browser over here. So let's go to our migration file. So we'll go here. And we already set this up for deploy contracts. And inside of here, basically, we're just going to deploy a new copy to the blockchain, but we'll extend this file to include also the exchange contract. Okay, so it's pretty easy. We basically just need to pull in the exchange first, like this. So we've got const token, we'll say exchange. And what we're going to do is basically deploy the exchange like this. We'll say, we could do deploy exchange. What we want to do is actually take advantage of some of the async await features inside of ES6. So we're going to say async function. We're going to use the await keyword inside of here. So we're going to await for deploy the token. And then we're going to say await deployer deploy the exchange. All right. And then we also need to pass in the constructor values for the exchange, right? We want to know the fee account and the fee percent. So we can set that up. We can say the fee account, we'll fill that in. And the fee percent is going to be 10. Okay. So how do we get this fee account? Well, I'm going to use Web3 to do this. And there's probably a better way to do this inside Truffle, but I'm just going to use Web3 because it's easy and it's right here. And I also want to show you that you have access to Web3 inside of this migration file. So we're going to use Web3 pretty extensively in the front end project. But remember from the introduction to Web3, basically we can get the accounts like this, a const accounts, await. Web3 ETH get accounts. All right, this is an asynchronous function call, and we're going to wait for it to finish, and we get the accounts like this. This is going to be an array of all the accounts that are provided by Ganache. So we'll see all these. All right, and we're going to get the first account in the list. We do that like this. We're just going to say accounts 0. All right, so we could refactor this to be a little more explicit. Let's do that. Let's say const fee account. So you can do this. And then we'll say the fee percent. This. All right, that looks a little nicer and a little more readable. All right, so we're going to get the accounts. We'll get the fee account with the first one. The fee percent will be 10. And we're going to inject those into the exchange. All right, so let's actually deploy these smart contracts to Ganache, to the blockchain. So we'll open Ganache, make sure everything's running, make sure that we have accounts with actual balances in it, and we're going to deploy to the blockchain like this. In the first couple videos where I showed you how to deploy it, we used Truffle Migrate, but we already have an existing copy of the smart contracts on the blockchain, or at least Truffle knows they've been migrated before. So what we're going to do is say -- reset. What it's going to do is deploy a new copy of the smart contract onto the blockchain because there's no way to update it, right? Once it's on the blockchain, it's on the blockchain. We can't push the source code again or the compiled code again either. Essentially, what we have to do is deploy a new copy. It'll get a new address, and that's what's going to happen with the reset flag here. All right, so truffle migrate -- reset, and we'll see what happens. All right, it worked. So we can see the output here. We can see that we started the migrations, right? Development. Deployed the migration contract first, and then it deployed the contracts. It replaced the token like I expected, and it deployed the initial copy of the exchange. We see the transaction hash, the amount of time it took, the gas used, etc., etc. All right, so here's the final summary, and here's how it worked. And we can also go to Ganache and see that the contracts were deployed with the transactions here. See contract creation. 3 different ones are created: migrations, token, and exchange. All right, so we have actually put these contracts on our development blockchain. later in the bootcamp, we're going to deploy it to a public blockchain, so don't worry, we're going to get there. But for the sake of just developing our client-side application, we're going to put them on Ganache, all right? So we've put them on Ganache for development purposes. But whenever we go to our exchange, we want to have data already in our smart contract for the exchange. We don't want to have to go to our UI and like add funds and make like a whole bunch of orders in order to see how the exchange works. We want to like come preloaded with a bunch of orders already. So I'm going to do that by creating a script inside Truffle that's going to basically seed the exchange. It's going to preload it with a whole bunch of data, right? So I'll do that like this. I'm going to create a new directory. I'll say, well, actually, let's just do this. We're going to go to the terminal, and I'm going to create a new directory that way. I'll basically just say make directory, mkdir, scripts, okay? And here's where we're going to put the scripts for our Truffle project. I'm going to create a new file called scripts, I'll say seed exchange. All right, and inside of here, we're going to create a seed script that's going to create a bunch of orders, execute some trades, deposit funds, all that kind of stuff. So whenever we load up the smart contract in the browser, it's already got data in it. All right, it's going to save us a lot of time. It's going to be really nice. So I will go inside of here, and I'm going to create a new script. Okay. So I also mentioned this is a script that's going to be specifically built for Truffle's script runner. So here's the basic skeleton of a file that can be run with the Truffle script runner. Okay. So what it does is we export an asynchronous function here, and it takes a callback function, and we must call the callback anytime the script is finished. And inside of here, we can really do anything. I'll just say console log script running, okay? And I'll go to the terminal, and I'll run the script like this. We'll just say truffle exec scripts, say seed exchange. And we'll just kind of see what happens whenever we run this script. All right. So the script is, we can see that it's using the development network, and we say the script is running. All right. So a console logged and it finished. So that's our basic skeleton for how the script works. Now we'll fill this in a little further. I'm actually going to, create a whole bunch of stuff inside of here that could potentially fail. So I'm going to use try. Say try, and we'll say catch error. All right, and we'll log the error if it happens. So we'll just do that like this. Basically just say this. Sorry. All right, so inside of here, we're going to console log script running. We're going to write some potentially failure-prone code inside of here, and not necessarily gonna fail. It's just if it does, we really want to know about it. And sometimes Truffle will suppress these errors, and I've gotten to really enjoying using this pattern and putting my script inside of here, just in case any failures do happen. It can happen whenever you're interacting with a live public blockchain, especially. Okay. So let's actually run a script to seed the exchange. The first thing we want to do is import our contracts, do like this. Just like everywhere else in the project, we say token equals artifacts require token, exchange equals artifacts require exchange. And now what we want to do is basically fetch all the accounts first. That's what we'll do here. So these will be unlocked, so we can actually do things with these accounts just like we did in the tests. And we want to get a copy of the deployed token and the deployed exchange like this. Say token equals await token.deployed. This looks a lot like our tests. And then we want to distribute some tokens, right? We're going to basically give some to the first account in the list. We'll do it like this. So basically we'll set up a sender is going to be account 0, and the receiver is going to be account 1. All right, and the amount's going to be 10,000 tokens, and we're going to transfer those to the receiver. All right, and then now we're going to basically create some users for the exchange like this. We'll say, it's user 1 and user 2, just like our test. This looks a lot like the test we just wrote. And what we're going to do is actually deposit some funds for each of those users. So user 1 is going to deposit Ether, and the user 2 is going to deposit tokens. And remember, it's a two-step token deposit process. They must approve them first, and then they must deposit them. All right. So this looks a lot like our tests. All right. Now, what we want to do is create a canceled order, just to prove that we have canceled orders. Because I'll show you when we build the client-side project, we want to take all the canceled orders when we show the open orders. All right, so do it like this. User 1 makes an order to get tokens, and then they cancel it. All right. And now we want to basically fill some orders. I'm going to do that like this. Basically, we're going to do this. All right. So user 1 is going to make an order. All right, like this. And then user 2 is going to fill it. And then because of how the timestamps work, we're going to wait 1 second. And then user 1 is going to make another order. And user 2 is going to fill it. All right, we're going to wait 1 more second. And then user 1 makes a final order. And user 2 fills it. And we're going to wait 1 second. So basically, we're creating 3 filled orders with timestamps. And we're waiting by 1 second to ensure that they're at least 1 second apart and there's no timestamp collisions, because 1 second is the smallest resolution that we have on the blockchain right now. All right, so lastly, we want to create some open orders so that we see, an open order book whenever we load up our exchange on the client side, okay? And I'm basically just going to do a loop and create orders like this. All right, so user 1 is going to make 10 orders. All right, so we're going to wait, exchange, make order token, address, tokens, 10. All right, Ether address. All right, made order from this. All right, et cetera, et cetera, et cetera. So that is our final script. And in order to do that, we've got a few other things we need to do. We need to add these helpers. So basically, these are going to be utilities from our test helpers that are going to get used inside of this, like, let's see, tokens and like Ether address. Remember these from the helpers? Well, we got to pull them in here, and I'm unfortunately just going to have to redefine them because it's hard for me to pull them in from the directory outside of this scripts folder. So Ether address, Ether tokens, and then also this wait function, all right? So that should be our completed script. Now, I know I went through that pretty quickly, but I'm including this script in the video resources, so you can kind of mull over this code yourself. But it looks a lot like what we just did in the test, so it shouldn't be too much of a new thing to you. But I should have talked you through all the sort of points to look at, especially this wait, and while we're doing that. So look over this more if you want to get a greater understanding, but I'm going to run it and just see what happens. So we're going to go to truffle exec scripts seed exchange.js. We can see the script running. Here's all the output. It's logging all of it to the console just like we expect. It's made orders, filled orders, and it's making new open orders. All right, looks like it's working. So I don't want to speak too soon, but let's just wait and see if it actually finishes. All right, it finished and it exited. So there we go. We have successfully seeded our smart contract with a bunch of orders. And we can go to Ganache and see that all these contract calls happened, and that there are accounts that have lost a lot of Ether. So that concludes this video. You have a smart contract on the blockchain, and you've got a bunch of data in it. So now let's go on to building out the client-side application.